In this lesson, we'll look at the Pi system environment at a high level, including its role in an enterprise, its major components, and an example of a robust architecture. The Pi system brings together different types of data into one central location. Within a large corporation, for example, it's very likely that there's pockets of data all throughout the enterprise. And while the sources of this information are very different in nature, the Pi system is designed to unify all of this, making it easy to organize and retrieve just the data that you need. Here, we see a sample company that's already implemented the Pi system. This company is split into multiple departments, and while this may represent a literal Pi system, it's better thought of as an enterprise-wide data infrastructure. It's where all your important data goes. It's also where you can reliably and quickly retrieve it. In an organization, there are many departments that altogether rely on similar sets of data, but just viewed from slightly different perspectives. It could be an individual looking at raw process data in real time, or creating monthly summaries for this process. The Pi system provides a suite of client tools designed to cater to all sorts of data consumers, no matter where they're located within an organization. Now, let's take a look at the major components of a Pi system. We see here that data flows from left to right. So we'll start off with the data source. And this is not typically a Pi system product. It usually represents a piece of equipment that already exists at the site. It could be something physical like a pump, or it could be a database that resides on a computer. Data is then fed next to Pi interface nodes, the first of Pi system products in this sequence. There are many Pi interfaces that each correspond to the vast number of data sources. Interface nodes know how to speak the language of both the data source protocol as well as the Pi server. So here is where data translation occurs. Two examples of Pi interfaces include the Pi interface for OPC-DA and the Pi interface for RDBMS. After the interface nodes, data enters and is stored within this region. Specifically, real-time data is stored in the Pi data archive. When users request for data over a specified time range, they are querying the Pi data archive for information. The Pi Asset Framework Server, or Pi-AF, contains metadata about the business or process. This includes data structured in a relational database, and also information about the assets of a company. We won't spend much time on metadata and Pi-AF in this course, as our focus will be on the real-time data flowing from data source to user. And lastly, data is then viewed from different client tools like PyCoreSite and PyProcessBook. These all fall into our visualization suite. Throughout this course, we'll discuss as well as implement many ways to create a more robust Pi system architecture. Here in this diagram, we see many different networks separated by these firewalls. On the left lie the data sources as well as the Pi interfaces. These can sit on a process control network, which is usually a very sensitive environment that many users shouldn't be accessing. Then data can be sent to a different network, here labeled a demilitarized zone, or DMZ, which acts as a layer between the sensitive process control network and the rest of the organization. In the DMZ, you see Pi data archives, as well as Pi-AF servers, in a sort of redundancy structure, allowing data to be available even in the event of a failure. Next, the corporate LAN, as I've mentioned, is where most of the users of the Pi system live. Here is where you can find the majority of the Pi client tools, like PyProcessBook, PyDataLink, PyCoreSite. Lastly, even from the internet or outside the company, controlled access can be granted to those that need to see the company's Pi system data. An example can be plant managers who need to monitor their process from home, or field technicians that need access to real-time data away from the corporate site. In summary, the Pi system is a complete infrastructure that collects data from all sorts of equipment and also serves this data to all types of users in an organization. Starting out small, a Pi system is designed to scale out to a robust network that takes into account security and fault tolerance factors. Next, we'll discuss what you should consider when planning your own Pi system architecture.